Welcome back. We're going to move into section 4b. We took a little time off. I had like 15 students to get caught up. Additionally, I kind of got sick, a little bronchitis, couldn't talk. Then I had a series of nosebleeds. Don't worry, I'm okay. But we should be in good shape now. The majority of the class is right where they need to be. So we'll be a little more consistent now. We're into a little more algorithmic material or formula driven. Um, Way easier on the instructor and probably way easier on most of you. Um, it's a good section. It's a compound interest formula, simple interest. Um, Plug things into a formula, get answers. Kind of real life. Go to buy a car, buy a home, things like that. These formulas govern that. Now, simple interest is, let's say it's a loan. Let me see if I can do this. It's A equals P1 plus RT, where P is the principal or the amount of loan. Let's say it's $1,000, and the rate is the decimal rate. So decimal rate, and that's like an annual percentage rate. And this is called the simple interest formula, like formula you can borrow money from mom and dad, that type of thing. So there's a decimal rate, so 10% really implies R is 0.10. 5% implies R is 0.05. So R is the decimal rate. So in math, we always use a decimal rate, but on the computers, most of the time you'd use the percentage rate. But we're going to use 0.05. Now T in these formula is in years, like 5 years. And this is the future value or final amount. So the final, let's see if I can undo this. There you go, final amount, or I prefer future value. Or if you're putting money into a savings, this could be present value. So it doesn't have to be a loan, it can be amount deposited in a savings account or a CD or something like that. But the thing is, banks normally pay things compounded monthly, so this formula doesn't work for that. Well, anyway, what do you say we do a little $10,000 at 10%? See how this simple interest formula works. So let's let P be, let's do 10,000. You got $10,000 laying around, or you want to take out a $10,000 loan? R, let's go with a little 5%, so a little 0.05, and let's go 10 years. Try to keep the numbers nice. So our final amount will be 10,000, 1 plus 0.05 times 10. You can use your calculator right now, but I made it work out nice. Move this over 1, so that'd be 1.5, $15,000. So, or try it on your calculator. Maybe I should probably double check. Let me give it a shot. 10,000 times 1 plus 0.05 times 10, $15,000. So simple interest formula. That's kind of how it works. The book doesn't do a great job with it. The book just kind of doesn't even mention it. I don't know why. Now, the book, I think, in an effort to try to make things simpler, kind of made things more complicated. But hey, I'll follow follow what they're doing. The book gives you the compound interest formula for interest paid once a year. So basically, here's how it works. If you had $1,000 and somebody had 10% interest, so times 0.1, you would have $100 in interest. So then at the end of the year, you would have $1,100. Then the next year, you take your $1,100 times 10%, and let me move that over to, you get $110. So now you add 110 to the 1,100, and you get $1,210. That's compounded yearly. So then you got your 1,210 times 0.10, and you get your $121. And then you add that, and you get 1331. I'll go one more time. Thinking my brain's gonna hurt here. 1331 times 10% is $133.30, which implies, okay, so that's called compounded yearly. You're just compounding it once a year. Versus the simple interest formula. So that was the money after 1 year. This is the money after 2 years. This was the money after 3 years. And this is the money after 4 years. Now if we use the P equals A 1 plus RT formula, the amount would be 1,000, 1 plus 0.10 times 4, 1,000 times 1 plus 0.10 times 4, $1,400. So if I'm saving money, I want compounded annually. Now, nobody wants to do this work right here. And you give me 9%, I'm not going to want to, I don't even want to do one step. So I picked 10%. Everything worked out good till I got to year 4, and then I'm going to start to worry. But simple interest is, well, you get less interest. So great if you're taking out a loan, I want simple interest. If you're putting money in savings, I want a compound interest. But here's what the book does. They give you a compound interest formula for interest compounded yearly. By the way, this is abnormal, so I'm going to give it to you anyway because the book does. So they write A equals P 1 plus, they call it the APR, annual percentage rate, to the number of years T. But unfortunately, our book calls TY, and I don't know why you do that. Years. Why for years? Oh, anyway, I'm going to probably use T and not Y, so please don't get mad at me. I'm just used to time being in years. I don't think you can get me right the Y. So, bottom line, in my realm, and you're like, whoa, that looks pretty similar to the other formula. It's not. They're different, and you get different answers. So let's try that last problem where I did all that work, calculated interest over 4 years, did the year, added it to the previous year. How about let's just do the 1,000, 1 plus 0.1 to the 4. 1,000 times 1 plus 0.1 raised to the 4. Whoa, 1464, 10 cents. Ooh, how did they get? Did I make a mistake? Three. Oh, yeah, right here. There we go. Fixed it. So, good thing because I didn't match. It's supposed to match. See, there's a chance you can make a mistake doing this repeated calculations. So, unfortunately, in the real world, it's not compounded yearly. And that's what this formula is. It's the compounded yearly formula. In business classes, this thing really doesn't exist. I'm going to skip to the real deal. This is the compound interest formula. And I'm going to have this variable n in my formula. I'll see what the book is. It's how many times per year. And I'm talking about compound. Oh, excuse me. M. I like M. Now, if monthly compounding, like banks, credit cards, just about everything in the world, if monthly compounding, compound at the end of the month, M equals 12. I would love monthly compounding. Yearly compounding did me pretty good. I made an extra $64.10. But if you compound it monthly, that's going to be even better. Unfortunately, if I do 4 years of that, that would be like 48 calculations, and I just don't have it in me. If quarterly, now, there are some things. I don't know if I spelled quarterly right. Compounding, it happens 4 times a year. I don't know if this ever happens. If weekly, M equals 52. If compounded daily, this would be really terrible to do the math, M 365. We could even do compounded every second if you wanted to, but like that's just crazy. Real life, M is 12. Anyway, here comes the formula. This is my formula, not the book's. Mine's better, but we'll break it down to the book. Well, how about let's start with the book. Excuse me, I'm adjusting here a little bit. There we go. 1 plus the APR divided by M to the MT. That's my, I guess that's the, sorry. You gotta understand, I've taught this for 20 some years, and I never used it. I never taught out a book that used their letters. So this is killing me. But it's all the same. Raised to the NY. Once again, I don't like Y because I like time for years, T for time, knowing it's in years. My formula looks a little cleaner. R over M to the MT. See, the book, they use N for what I want to call N, and it's just a number of compounding periods per year. Technically, the book is probably right, but N is used for so many things in math, it just kind of is overused, so I don't want to use N either. All that said, let's do the problem, but let's compound monthly. I would love to know the final amount of $1,000 at 10% compounded monthly to the 12 times 4. Now, I'm going to start being careful because a lot of you don't have the fancy calculators. So 1 plus 0.1 divided by 12. Give yourself plenty of decimals. 6, 7 decimals. That should get it done. 12 times 4, 48. So this is what you do if you don't have a fancy calculator like me. You do this math, you get a whole bunch of decimals. Then you go 1,000 times 1.1281233. You can go a lot more than you had. Raised to the 48. Whoa, yeah. Look at that. $1,489.35. I used to have 1464, now I got 1489. Yeah, that's like 25 more dollars. I love compounded monthly. Compounded monthly is a good thing. Make a little more money. I know you all thought you were going to make a lot more money. Unfortunately, it doesn't work that way. If you want to be really disappointed, you should let M be 365. Actually, let me give it a shot. So let's compound it 365 times a year. 10%, 365 times to the 365 times 4. This time I'll use my fancy calculator. 1 plus 0.10 divided by 365, parenthesis raised. Now, you can keep it raised. I think I'm going to put a parenthesis, 365 times 4 parenthesis, just to make sure it stays up there. Or do this calculation, about 7/10 decimal places. Do this calculation, and then rewrite it, and I'm going to get the answer. And look at me, compounded every day. Remember, it's money. So if it's money, you got to look at the third decimal. And then you go 1491.74 because that number was less than $5. All right. So that formula, I use it all the time. For example, let's say I want to buy a brand new, right now, a Dodge Ram. So a Dodge Ram, 2,500. I'm not going to actually get the diesel. I'm going to go with 6.4 liter V8 Duramax. I don't know. I like the diesel, but I just don't really need it. I might pull a trailer sometimes, so I want to get that. I want to get a truck that's a little bit better than a work truck. Now, outright, the truck I want is about $60,000. So I want to take out a loan for about $60,000. Oops, one more zero. And at 3.9%, see, 3.9% is 0.039 divided by 12 to the 12 times, well, how long is that going to be? Well, $60,000. You want to go 5 years? Let's go 5 years. So let's do it like amateur / person that doesn't have a fancy schmancy calculator. 1 plus 0.039 divided by 12. Ooh, 1.00325. Now, since I have it on my calculator, I'm going to go raise it to the 60. And then I'm going to go times 60,000. And that truck will cost me $60.06. Take that, round up. That'll be the total cost of my truck over 5 years. Now, divided by, so you take your amount final, so your amount divided by 60, and that's going to be my payments. So divided by 60, and I'm going to be paying 1214.92693 per month. And then at the end, you might be off by 21 cents or something like that. Is that my real scenario? No, not my real scenario. Just so you guys know, I'm actually a home inspector. It's like my retirement career job. And bottom line, because I have a company, this $60,000 truck, I can basically write it off in one swoop. It's a tax write-off, meaning let's just pretend I made $60,000 this year, and bottom line, I just write the truck off, so it means I made $0. So you go $60,000 in profit in your company, but you buy this truck for $60,000, and it's a 100% tax write-off. The government taxes you at $0. But my taxes for my company, with all my expenses, deductions, and everything, with Trump's new tax laws, all that stuff, I'm really literally running about 17 or 19%. So let's say it's 60,000. Let's even say times 20%. So if my company is going to be run, if I'm going to be paying my taxes, it should be around $12,000 if I didn't write it off. So I'm going to take the $12,000 and put it down on this truck, because if I waited till December, I have the $12,000 in my account. That's $48,000. Now, what I've been doing is every month for 2 years, I just make a fictional truck payment into an account. So literally, I'm putting $24,000 down. So I'm going to take out a loan for $24,000 over 3 years. But guess what? They have 0% financing over 3 years. If you go 4, it's going to cost you some interest rate. So bottom line, I need to pay $8,000 per year, or $8,000 divided by 12. I need to make 666.67 payments for 3 years, because I actually planned. I've probably bought 10 vehicles in my life, and usually I have 5-year loans, 6-year loans, things like that. Now that I'm a little older, I always see that 0% financing, and I've been planning for a few years, and I actually avoided, for the first time ever, or will be avoiding here in December, using the formula. Another thing I should probably share with you is, let's do a house loan problem. And then I should probably get back to reading the book. See, my lectures only have 24 minutes. This is something I'm very, 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 very comfortable with. versus some of the other sections. They're tough, as you know. They're tough. They're they're not very exact. There's a lot of flexibility in your solutions and kind of it just this. I don't know. I found it hard. I think you did too. But let's buy a home. So here's an example. Even a condo. So in today's market, a condo costs about $300,000. Yes, you can still get them for 240, and the rate is about 0.325%. It will be compounded monthly, 12 and over 30 years. Typical house mortgage over 30. Now you're not going to be feeling very good about this for your $300,000 home. Let's see how much you're going to pay for it after 30 years. So 300,000 times 1 plus 0.0325 divided by 12 raised to 360. Whoa, don't cry. 794,302.64. Yes, that is the final amount, is the P plus the interest. And if you go minus $300,000, you paid $494,302 in interest. Go back up, take that number, divided by 360, and your payments, woo, are 2,000. I guess they are. Yeah. So your payments, you gotta understand, I haven't ever had a loan that big. So, I bought my house and it was like $130,000. So, granted, it's not the nicest house in the world, but it's in Denver, so it's actually worth some money. But I got a little caught off guard there. So your payment was the 794,302.64 divided by. Oh, did I miss? I want to double check. Did I actually do the calculation right? Yeah, I did. Okay. Divided by 360. And I picked up $2,206.40. Ooh, those are pretty big payments. So this formula works really good, but you got to have it work the other way also. You got to be able to solve for P. So the nice thing about this class is they kind of just give you a formula for everything. So let's start from the beginning, and it'll kind of be a summary, and then we'll be done. So our first formula was A equals P 1 plus RT, and that's the simple. If you want to solve for P, it's A divided by 1 plus RT. So if you want to know, if you got a final amount that you want to have saved, and you know your rate and the time period, you can figure out the amount that you need to put into your savings account. And the second formula, which I am not a big fan of, is the compound once a year formula, but P is just A divided by. And then finally, 1 plus R over M to the MT. That's the true compound interest formula, the formula that most of the world revolves around. And P is just A divided by. Now I'll tell you, as long as we don't have to figure out the time, these problems are doable. But if we have to switch the time, then we have to bring in these things called logarithms. Or Verbsky has to just give you a formula for time. If I were you, I just prefer that Verbsky gives me a formula for time and you just plug in the numbers and then we can skip the whole logarithm discussion. With that said, uh, I'm going to rally and I'm going to make an assignment and I'm going to try to work it in the next, well, hopefully have it done by Saturday and post it. I'm going to assign quite a few problems because this is real life. So it'll be a little bigger assignment. You're going to want a calculator and you're going to need to know how to raise something to an exponent. So I hope we get through that. I know my phone does it, but you might have to actually do a little YouTube tutorial if you're not using a calculator like a TI-83 or 84. I have a bunch of things to show you. The TI-83, 84 is like super nice. It like does a ton of work for you under finance mode solver, 360 payments, interest rate 3.25, take out a loan for $300,000 and payments, I don't know, future value, I don't know, but payments per year and compounding per year is both 12. And I want to know my future value, alpha enter, whoa, 794,302.64. You see, I don't even really need the formula because somebody's programmed that thing into my calculator. So there's all these Excel. It actually does a bad job, but the TI-83, 84 family does pretty much all math. Hewlett Packard calculators have all this programmed in there, but we're not getting into that here. So this is the end of the first lecture on this section. It might be the only lecture. Kind of hoping so, but we'll kind of see how it all works out. This is Verbsky, over and out.